On this episode of Double Stranded, I am joined by Dr. Phil Ewels. He is one of the key minds behind some of my favorite bioinformatics tools, and probably yours too. See if any of these ring a bell. MultiQC, Nextflow, NF-core pipelines. I personally use these tools almost every day and had a blast talking to him about them. If you want to see more content like these, please consider subscribing right now. And with that, here's my conversation with Dr. Phil Ewels. So, yeah, I would like to know the origin story of Nextflow.
Yeah, absolutely. So Nextflow was developed at the CIG in Barcelona and was an academic project in the lab of Cedric Notre Dame. Paolo de Tomaso was a developer in that research group, and they worked a lot with multiple sequence alignment. So that group developed T-Coffee, which is a very well-known algorithm. And I think the project started off that Cedric wanted them to kind of try and run it at a large scale using this newfangled cloud, which everyone was talking about. And so Paolo kind of took this off and built what became Nextflow, because he wasn't satisfied with existing systems and kind of workflow managers. And that kind of explains why from the start Nextflow was built to transition research workloads from like HPC, which is what the group was using, to cloud native. So that's how. So I wasn't involved at all in the start of Nextflow. Actually, I was busy building my own workflow manager at that time called Clusterflow, and I kind of came into the story a couple of years later.
Oh, that's interesting. So correct me if I'm wrong, but like the whole project was started as like kind of like a research thing, not like an industry themed issue. It was just like pure research, like, and later on it just developed to this like beautiful community and everything around it. And we are also going to talk about NF-core pipelines a lot. So if you just like give us a brief overview of like NF-core pipelines and what they are and what was the purpose behind them.
Yeah, absolutely. So Nextflow passed 10 years old a little while ago, and I was based in Sweden when I found out about Nextflow, and my tool that I mentioned wasn't really scaling very well to the workloads that we were trying to handle. This was at SciLife Lab, where we're a national genomics platform for Sweden, so we're handling kind of many projects. And so we found Nextflow and started building pipelines for Nextflow instead, and had like a portfolio of different pipeline types, because we were building analysis pipelines for all the different protocols that we ran in our kind of core genomics lab. So we started with methyl-seq and for bisulfite data, and then we kind of were doing RNA-seq and ChIP-seq and ATAC-seq and so on. And then the Nextflow community was really kind of starting to grow rapidly at that point. And at the CRG, it was all very academic at this point. It was the first of what became an annual event around the Nextflow community. I think it was called NF Hack or something like that. NF Hack 17 or NF Hack 18. And so Paolo and I knew each other relatively well by this point, despite how much I'd bothered him on the message boards. We used Gitter for instant messaging back then. And so he invited me over as a speaker, and I presented what we were doing in Sweden, and got to meet a lot of other kind of Nextflow enthusiasts who'd come from all over. And that was kind of how NF-Core was born then. So I was very lucky that people liked what I was doing and what we were doing in Sweden. It was already a team project by then. And I kind of basically did a bit of trotting, went around giving talks about the project. First in Singapore, and then in Tübingen in Germany, then later San Francisco and London. And kind of out of those initial collaborations, we formed what then became NF-Core, where basically we took the pipelines we'd already started, ripped off all the branding, gave it a new name so that anyone could contribute, and then kind of set some guidelines about how we wanted to kind of form this global collaborative environment where basically, I guess it's difficult to imagine this now, but at the time before Nextflow, it was very difficult to make a pipeline which was truly portable. So if you wanted to do an RNA-seq pipeline, there are a bunch of tools to do it, and you would write it and it would work on your system, but it wouldn't work for anyone else because it was really tied to local environment modules or local installation and stuff. But Nextflow brought this concept of tight integration with Docker and Singularity, tight integration with Git and code sharing, and this idea of handling all these different executors, so running on all these different compute systems. And that meant that these pipelines are really portable. And that was the first time I'd ever seen that actually achieved. And what that meant was suddenly people didn't need to build their own pipelines for their own institutes anymore. And instead of 100 people making 100 RNA-seq pipelines, the whole point of NF-Core is like, okay, let's everyone come together and build one really good one.
Yeah. And so when you started these like NF-Core pipelines as a project, like, did you know from the get-go that it's going to be like as many pipelines as we have today?
Absolutely not. No, I mean, we started with it was probably about 7 or 8 pipelines at the start. And the reason we called it NF-Core was that the groups in Singapore and in Germany were other core genomics labs like us. And so I had initially imagined that other core groups around the world who are doing the similar thing of handling lots of different data types might be interested as well. You know, maybe we might get a few people here or there. I've started quite a lot of projects in my time as bioinformatics, and most of them, you know, some people find useful, and then you move on to something else. NF-Core was the right thing at the right time, and really, although NF-Core is separate from Nextflow and grew separately, it's very symbiotic with the two, and the two really kind of grew together and just really hit it off. And I've said it before. I remember like Paolo sharing our first tweet and me being like, oh, I wasn't really ready for that. Like, and I remember when we hit like 100 people and being like, okay, this could really like get quite big.
Yeah.
And now I think we're over 11,000 people on the NF-Core Slack.
Wow.
So yeah, and so I can't remember 70 something released pipelines, but more than that for pipelines. If you include those in dev and archived, we've got 125 as of today.
Wow. Yeah. But I mean, I can totally understand like 77 pipelines because I mean, I think it's just so popular and everyone needs it. So this is actually my first question, I guess. I was gonna ask you about like, what do you think were the key factors that contributed to its success and like a widespread use in the bioinformatics community? But I think a great angle to start would be, so you mentioned you had your own pipeline management thing that I never really took off. So like, what do you think were the reasons that your tool didn't really take off, and like, what did you learn from that experience that you brought to the table when you were like working on the Nextflow?
Yeah, good question. And I feel that my experience in that first tool did inform a lot of what went into NF-Core. I feel like I kind of tried to take the best parts of both tools. What didn't work very well with my tool, it was called Clusterflow, was that it didn't scale very well. So the kind of the software engineering side of things wasn't very strong. That tool worked by submitting a whole load of jobs to your cluster, and then that was it. It exited and just let them run, and it was up to the job scheduler to make sure that they ran in the right order and everything. If anything went wrong, sorry, you're on your own. You've got to start it again from scratch. Once you started scaling up to really big numbers of samples, it would take a very long time to figure out what jobs to submit, and it would hit the scheduler with not just all the jobs in the first step of the pipeline, but for every step of the pipeline. So it would hit the job with the cluster with thousands and thousands of jobs in one go in a single submission. So it didn't scale well to large projects, and it wasn't really kind of production grade for when reliability starts to be really important. So those are kind of the reasons I moved away from it. The things I tried to take with me were 2 things. User friendliness, so kind of just ease of use, and having things like many of the NF-Core pipelines have ship with configs for reference genomes. So you can just say ---- genome key, GRCH38, whatever. That idea came from Clusterflow, where it had built-in genome reference management. And also the idea of having pre-built pipelines that you can use off the shelf. With Clusterflow, they were built into the tool itself. But with NF Core, still the idea is the same, that you can kind of just take a command line option and just be like, okay, just run some RNA-seq, and it would kind of knows what to do.
Great. So the whole concept of like Nextflow and like, well, I guess NF Core pipelines is about standardization, which often involves trade-offs. So how do NF Core pipelines balance the need for like reproducibility while still allowing flexibility for researchers to customize their analysis?
There's lots of answers to this, but I'll start with reproducibility, because I think that's at the core of everything we do. The things that Nextflow and NF Core together do really well for reproducibility is we piggyback on some greats in the industry. We use Git. Git underlies everything we do, and so that gives us version control of all the pipeline code. So we can say, okay, version 1.4 is this commit hash, and you can go back in time and you can see the state of the code every single release, and you can continually develop while kind of tagging those versions. So that's number one thing. Number two is software, because it's no good in releasing updated code, or if you go back and all the software has changed, then your results are not reproducible. And there we use software packaging solutions. So Conda was the first, and then really what's driven it has been Docker, Singularity, and other container technologies. And so what we can do with these is we can say the software is packaged up typically now for every step in the pipeline has its own image. And those are also kind of version controlled, because each container has its own address, its own tag. And that is hard-coded within the pipeline code. So that means if you go to an old version of the pipeline code, the old versions of the containers will also be referenced there, which means you get exactly the same version of the software that was in that version of the pipeline. And so that means you can check out, and really is just -r version number in the command, so it's very easy to do. You can check out any old version of the pipeline, run the same code and the same software from whenever that came from. So reproducibility is really, really good. In terms of trade-offs, the standardization comes at a bit of a cost, because obviously we have to agree on what the best practice is.
Yeah.
So that's kind of one of the fun parts of the community, is kind of discussing that and trying to work our way forward. And there's always kind of, how paranoid are you? You can really fortify everything with masses of code, which tends to be where we end up with NF Core. You could go a lot more lightweight than NF Core if you want to build a pipeline with Nextflow, but we try and really kind of be best practice. And the other thing is standardizing across different pipelines. So something we built up during the course of NF Core is that the idea of having a template. So every NF Core pipeline is built from the same template, which gives the same kind of boilerplate code. Structures of everything in the same way. And when you fix a bit of code in your pipeline, which is from the template, we encourage you to kind of put that back upstream. And then we do new releases of a template, and we have automation in place, which opens up pull requests against every single NF Core pipeline and tries to synchronize those changes in like the boilerplate code against everything else. And so they all get brought along together and hopefully all stay approximately in sync with one another.
Great. And I would love to know about the process that you choose, like, because like when you think of a NF Core pipeline, each step, like you can choose many tools to like use there. Like when I think about a Taxic pipeline that I use almost every day, like for each step, like you have many options to choose, and I would love to know the process like behind this design, that like how do you decide which tools to choose? Do you guys like have a SOP like procedure that we're just gonna like check these measurements, I don't know, on the output of each tool, or is it just open to the community? Like you guys, what do you guys like what is the process?
So NF Core is very grassroots. There's not very much kind of central control. And part of that is that we have, what did I say, 125 pipelines. That covers every discipline of genomics pretty much, and beyond as well. We have pipelines for imaging, for proteomics. We have one for detecting neutron stars and like Earth satellite data. We're kind of reaching outside of bioinformatics a bit now. So there's no way that a single group of people can be domain experts in all of those different types of research. So we kind of consciously defer to the pipeline developers for any given pipeline. And that's a self-selecting group of people that often overlaps with the people using that pipeline. So basically, if you're doing research in a TaxSeq with a TaxSeq data, and you look at the pipeline and you think, oh, well, this new tool came out a few months ago and I think it's much better, then we invite you and anyone else who's in a similar position to come forward, discuss it, propose it, and then submit code changes to add that tool in. In terms of all the different options, the strategy that we try and go for, the same for NF Core as it is in anything I write really, is I try and think about lots of customization, but having sensible defaults. By that, I mean, you should be able to run the pipeline with almost no options. It should just, out of the box, should just do what the consensus of the community is that is the best thing. However, it should be possible to go in and tweak it however you need to. And we kind of have different tiers of that in NF Core. Like there's kind of parameters, like different options for the pipeline, which can turn things on and off. So whenever you do dash something, when you run an NF Core pipeline, then that's probably configuring some kind of common behavior or common pattern. And then you can kind of really get into a nitty gritty where there's a way to supply configuration, which will basically let you specify any custom flags to any specific tool within the pipeline. So you can really change pretty much anything without actually editing the pipeline code. And of course, if you want to, it's all open source, so you can fork the pipeline and do whatever you want.
Great. That's interesting. But so when I look at a TaxSeq pipeline, it's like, but correct me if I'm wrong, but you guys couldn't or didn't want to decide on one aligner tool, so you have like a few options. I think this is one of the only steps that like you have many tools instead of one.
Yeah, this is quite common. One of the founding principles when we built NF Core, we kind of have this set of guidelines where we say, if you're going to bring a pipeline to NF Core, build a pipeline with NF Core, these are the guidelines you have to follow. And one of the ones which is probably differentiates NF Core from other communities the most is that we say there must be only one pipeline data/analysis type. So there are thousands of tools for RNA-seq, and there are thousands of different pipelines which do RNA-seq analysis in slightly different ways. But NF Core has one pipeline called RNA-seq, and it has one pipeline called the TaxSeq. And the reason we do that is we don't think we want to present to end users, like we don't want someone to turn up and say, oh, okay, there's 6 different pipelines and I have to figure out which one's best.
Yeah.
And also we want to focus all of the collaboration development efforts into a single place. So we try and focus everything into one pipeline, which is good, except if you have 5 people using a TaxSeq pipeline, one person's doing it on plants, on Arabidopsis, one person's doing mouse, someone's doing it on, I don't know, all these different organisms, different data types. Everyone has different use cases, and there isn't one situation fits everyone. So we try and set defaults which work for most people, but people will always turn up saying, I want to use this different tool, or in this case, this one does better for me. And so in order to cater for that, we say that pipelines can contain kind of multiple routes, basically, which in this case is choosing a different aligner. And if you look at some pipelines, I mean, the methyl-seq pipeline is basically 3 different pipelines just in one. And you say, okay, I want to use this chain of tooling, or, which is like Bismarck all the way through, or you can say, I want to use BWA meth and methyl dacol. And it's almost a different pipeline, but it's, the same command, and you just kind of flip a switch.
Great. And before we get too technical, I would also like to ask about the FAIR framework that you guys in your, I think, NF Core paper mentioned or somewhere. Can you also elaborate on that and your vision with this framework?
Yeah, so for anyone who's listening who's not familiar with the acronym FAIR, or you're going to test me now, does it stand for? Findable, accessible, interoperable, and reproducible, I think. And typically when this is kind of talked about, it's often talking about like data or tools or software and things like this. And it can be applied to pretty much anything in research, but we think that kind of NF Core follows these principles as well as we can, basically. And so for kind of all of them findable, you centralize a lot of knowledge. We spend quite a lot of time thinking about outreach, training and things like that. So we try and make the pipelines as findable as possible. I think we're doing a pretty good job with that. Accessible, that's the stuff about kind of sensible defaults, making them easy to use, easy to run. Also, really high bar when it comes to documentation. So we really kind of try and insist that all the pipelines have really good documentation. Every option must be documented about what it does and so on. Interoperable is things like kind of selecting sensible data formats, so that we're not, where possible, we kind of adhere to industry standards. And also interoperability means like we try and, where possible, every pipeline will support Conda and Docker and Singularity, and we try and make everything work on as many different compute infrastructures. We test everything on cloud and on GitHub Action. Like we try and really make everything interoperable everywhere. And reproducibility, I already talked about a little bit.
Great. Yeah, in terms of making sure that the pipelines are reproducible, have you conducted any stress tests where NF Core pipelines were run on different data sets or hardware infrastructures or cloud environments to evaluate if the results remain consistent? And if not, how do you plan to test this rigorously?
Yeah, so actually the original Nextflow paper, published quite a long time ago now in Nature Biotech, that was the main focus of that paper, was looking at the reproducibility of analysis. And back when Nextflow was started, the containerization and Docker was quite a new concept. Most people working in bioinformatics hadn't really come across it. And that was one of the main points of the paper, was that using Nextflow, which is pinning all the software versions, pinning the underlying dependencies underneath those softwares, because you have the shipping and almost an entire operating system inside a container. And kind of having that deep stack of reproducibility within the pipeline analysis gave more reproducible results. So it's a very short read. It's only like a page of text. So it's one of these kind of, these papers, it takes a lot of blood, sweat and tears to do when it comes out, and it's only this long, but it's a nice read. So I recommend having a look at that if you're interested. There are also many, we're a community in open source. We say all the pipelines are community owned, but that doesn't mean that the people writing the pipelines can't write publications about them. And if you go to the NF Core website, you'll see under About, there's a page called Publications with a long list of all the different publications about different pipelines. And so many pipelines, you can find that someone has written a publication about that specific pipeline, and most of them often come with benchmarking. So off the top of my head, for example, I think there's 2 papers now about the SAREC pipeline, which is for whole genome sequencing and cancer, or just regular germline samples, and that's got a lot of benchmarking in it. So there's no comprehensive answer for that. It's not a one size fits all. It's really it's kind of technology specific is that the Nextflow paper, and then pipeline specific is up to all the different pipeline authors.
Is there any element of randomness built into the Nextflow pipelines anywhere, or?
You mean numerical randomness, or you mean what kind of feature randomness?
Well, I guess anything that could potentially cause the outcomes to be different, not necessarily meaningfully drastically different, but I don't know, maybe 4 digits after the decimal point or something.
Yeah, that's kind of partly what the paper's talking about. The original Nextflow one is saying that, for example, binaries in the underlying operating systems might calculate random numbers in a different way. And sort of the deeper that kind of reproducible stack is within a container, the more standardized things like that will be. Some pipelines have inherent randomization within them, random seeds are used differently every time. That's kind of part of the analysis. So, realistically, nothing is ever 100% reproducible, but we do our best. What I thought you were asking first, which I think is also quite an interesting question, is the kind of feature randomness, which is okay, this pipeline uses this tool. Why did you choose this one and not that one? And that's definitely an element of randomness. And it's usually well, the person who turned up and put time into writing the pipeline, that was the tool they wanted. So there's a certain amount of randomness as to which tools are included in any pipeline. And so I would say to anyone listening, never be put off if a pipeline doesn't include your favorite tool, it's probably just that no one's got around to adding it. And if you want to come and add it, that's usually very welcome.
So we know that many bioinformatics tools struggle with scalability, especially with the exponential growth of sequencing data. Do you believe that the NF Core framework is truly future-proof, or will new paradigms eventually render it obsolete?
I think nothing, it depends how far you look. Nothing is future-proof forever.
Mhm.
Um, we Some things make me optimistic. The community of NF Core makes me optimistic rather than the pipelines themselves. My hope is that bringing together the people, the expertise, the attitudes, and the feeling of collaboration means that as one technology becomes obsolete, another will emerge and we'll be ready to build a new pipeline for that. So that's kind of one way to tackle that. On a more technical level, there's a question of kind of whether Nextflow itself can keep scaling forever to
Mhm.
like infinite numbers of job submissions. And I mean, so far, the answer to that question has been yes. I mean, really, the underlying compute systems have been scaling enormously. And you need to look at some of the runs that people do on the cloud now. And so far, I mean, the work that Nextflow has to do is relatively light, really. It's kind of almost acting as a kind of glorified job scheduler. But basically, Nextflow, for the most part, seems to scale very well. It's one of its main selling points. And regularly now we see people running a single Nextflow pipeline run with certainly hundreds of thousands, if not millions of jobs within a single run.
Yeah, you also mentioned, I didn't know when I wrote this question that you guys have NF Core pipelines for things outside of genomics, and I would like to know about that as well. And like, how did it happen? Because I don't think it was your initial plan.
No, I mean, our kind of core user group is certainly genomics. That's where many of us started off working as researchers ourselves, and that's kind of where most people know us from. But there's definitely, especially in recent kind of year or two, been starting to see some expansion beyond that. We've always been open to having any pipeline from anywhere. Nextflow and as an extension NF Core is a specialty, is all about kind of workflow management and
Mhm.
computation. And there's nothing inherently biological or genomic about that. And so what we started to see is that kind of people on the fringes of genomics who are working in multiple fields are starting to like what they see with the genomics pipelines and wanting to apply that to the other fields they're working in as well. And so I think before I mentioned like imaging,
Mhm.
so spatial transcriptomics and things, for example, that's kind of a combination of microscopy and genomics. There's also people working in proteomics, proteogenomics. And then there's kind of a few pipelines which are just completely different. So quite early on, we had one called Spinning Jenny, which is
Mhm.
one in economics research.
Hmm.
Um, and then we've had one called Rangeland, which is, let me get this right. I'm going to check. That's the one for satellite data. So kind of, satellites of the Earth. And then there's one called MeerPipe, which takes data from the MeerKAT telescope, radio telescope, and looks for pulsars. And so they're completely different. And there's one for detecting neutron stars as well. And I've forgotten the name of that now. So
Hmm.
if you look at these other fields, satellite imagery data, actually the analysis is quite similar to microscopy image analysis. And same with like pulsar data. These are big data sets sat on the disks, lots of I/O, lots of sequential analysis and job orchestration. And so they're completely different scientific realms, but actually their needs for computation are quite similar to genomics, and so it's a good fit.
Hmm.
Probably the most difficult thing is the human networking. So
Yeah.
people working in physics or whatever have never heard of Nextflow, have
Yeah.
no idea what NF Core is. So it's just kind of getting the word out to those people that this is a tool that they can use and showing them. And that's a slow process. But I very much hope that word gets out and that people see the value in these tools and you can see continued growth of the community in these other domains.
Great. And well, based on these like pipelines you mentioned in all these different areas, it looks like the NF Core thing is very well-rounded and diverse. And so I would like to know about the NF Core team as well, like the core people who write the code, and what are their backgrounds, and like how did they become involved?
So I mean, we have a kind of governance structure for NF Core, so we have a core team, which is not the best name, NF Core. And then we have, like an outreach team and a maintainers team and a steering group, which all came out pretty late, to be honest, given kind of how big the community's got. But we kind of decided we needed some structure around basically what we were already doing. And so those people are kind of self-selected more or less. It's all written out. We have a governance page on the website which explains how this all works. And most of us are basically people who have worked with NF Core for a long time. So as a result, most of our backgrounds are genomics, majority academic, but we have more and more people joining us from industry now, and so on. You mentioned developers. I mean, we have many hundreds of developers. If you look at the people who've contributed on GitHub, and that's really very specific to pipelines usually. So the people working on the astronomy pipelines, their background is astronomy research, and so on. But for the most part, people are scientists working in their domain, not, for example, software engineers or anything else.
One of the amazing things about NF Core pipelines, at least the ones that I use, is like at the end you'll get everything in this like beautiful one-page report called MultiQC, which I'm a big fan of. So before I ask my question about MultiQC, maybe you can like explain what it is, and also do you include MultiQC or something similar in like other pipelines that are not like genomic based?
Yeah, so MultiQC is a totally separate project to Nextflow, and of course it's completely independent. It just chanced that I wrote that as well. So it's actually, it predates certainly my usage of Nextflow by a little bit. It was born in a similar situation where, again, this one was soon after I moved to Sweden and joined the genomics group. And because we were processing so much data, we were trying to do QC on all this data before we sent it out to the different research groups. And I just would see our team of bioinformaticians with like 50 FastQC reports open in different browser tabs and sort of digging in a terminal through all these log files, looking for, what percentage of duplicates or how much adapter sequence was trimmed. And I kind of thought there must be a better way. And so I built MultiQC. And for anyone not familiar with the tool, basically the concept is it's a command line tool. And you say, here is a big directory full of files of my analysis, which I've already run. MultiQC doesn't run anything for you. And it's got two steps. It finds all the files it thinks looks interesting, and it digs through them, and it pulls out all the relevant metrics, which for the most part is basically kind of glorified regular expressions. Just like opens a text file and looks for a pattern, pulls out a number. And then there's the second step where it generates an HTML report, which is hopefully kind of human readable, and also dumps all the files, the data into nicely formatted files if you want to do downstream analysis. Because I guess maybe it's natural that I both at MultiQC and NF Core kind of came out of the same research group. Basically, at SciLife Lab, we were doing the same kind of work. The two fit together very nicely. And so now, as you say, many of the NF Core pipelines have MultiQC as like the final step, and it sits very nicely. It doesn't matter what workflow manager you're using, whether it's SnakeMake or WDL or Nextflow or whatever. You can stick MultiQC at the end and just give it all the files from the pipeline run and say, give me a report. And by and large, it does a pretty good job. I think it supports something like 150 something different bioinformatics tools now. So it covers many of the kind of common tools out of the box, and hopefully does a decent job of kind of summarizing all that data. The second part of your question was, can it be used outside of bioinformatics? Kind of, I guess, similar kind of vein to NF Core. And very similar answer. There's nothing in the MultiQC code base which makes it genomics specific. The only thing that's specific to genomics is just its history, its users, its developers. And so that's kind of been its core use case. But I know for a fact that some people are using it in chem informatics, in chemistry, and people have used it in all kinds of stuff. Um, those 150 modules built into MultiQC, those are specific to tools, and they are almost universally bioinformatics tools, mostly in genomics. However, you can give MultiQC data from anywhere. As long as you format it in the correct way, it's called custom content. And if you give it like a file name _MQC, you can give it any CSV file or whatever, and MultiQC will chuck it into the report and do its best with it. And so that's a bit of a black hole. I guess like I have no idea what people are doing with that part of the tool because there's no way for me to see that really. I just get the occasional bug report. But there's absolutely every chance that people could be using it for all kinds of different types of data.
Great. Yeah, I was gonna ask about like when I wrote this question, I was just thinking about like MultiQC that I get and like see after the ATAC pipeline. But so now this question kind of sounds dumb because you mentioned all these like other NF core pipelines that like could be about anything, not just sequencing data. But I was gonna ask about your like favorite feature in a MultiQC report. Like if you could just choose one metric to just look at, and like based on that you will like decide on the quality of the pipeline run and everything. I would personally just look at the PCA plots these days, and I think they're really very telling. But yeah, like maybe we can just narrow it down to like genomic based pipelines.
I mean, you kind of hinted it in your question, but it depends very much on what you put into MultiQC. Some people use MultiQC basically as a glorified version of FastQC and just pull in FastQC reports, in which case that's all you're going to see. So it very much depends what the data you give it. But when we write MultiQC code, or when we review code written by the community, we try and kind of really think about what the tool is doing, and what the most important things are from it. It's very easy to try and stick everything into a MultiQC report, which we push back against. We say, okay, what are like 2 to 4 metrics which really tell you the most? And that's what's prioritized. And that's what we have a table at the top called general statistics, which is where all different metrics from different tools, so different parts of the pipeline, kind of stack up alongside one another. And you start to see patterns, and then everything else we kind of plot in a way that hopefully makes as much sense as possible. So I can't really give you one answer because it depends on the pipeline, and it depends what you put into it. But hopefully the way that we build MultiQC and structure the reports, most of the time, the first kind of view you get of a report will give you a bit of an idea quite quickly. And also, I feel compelled to do a little plug for the most recent feature that we just released just a few weeks ago. Version 1.27 of MultiQC came out, and that new feature for there is AI summaries. And it's kind of really interesting seeing what people think of it, because some people are like, oh, seriously, there's like AI saturation it's being added to everything. Like MultiQC is already summarizing data. Why do you need summaries of MultiQC reports? But I mean, but what you were saying, I think, fits really nicely with what AI can do, where especially if you're new to this analysis type, or you're new to bioinformatics or whatever, AI summaries are pretty good at being like, okay, these samples like have bad duplication rates or whatever. It's surprisingly good at pulling out outliers. And if you have massive reports with thousands of samples, pulling out kind of patterns or lists of samples which look bad, or things that might kind of fall off that first scroll of the report. And it's also quite good at explaining stuff. So there's now little buttons next to every plot and every table where you can get a summary of that plot, and it will go some way towards explaining what the plot's trying to show you as well, which supplements any documentation and help text which is already there.
Great. Yeah, I was just gonna ask about that AI integration, which you just answered. But I think, I mean, I would personally still download the whole thing and just like take at least 5 minutes to like go through all the reports. But I think I was gonna like mention this like towards the end of the conversation. You have this like mini project for SRA data sets that you just like, it's a web-based tool that lets you just like look up data sets in Geo and SRA, I was thinking that it would be great if you could just like make it kind of like a I don't know, conversational AI that like, hey, I'm looking for a data set of RNA-seq about like this cell line, blah 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 blah. Here's some details. Like go on SRA and like give me a list of all the data sets that I could download and just like give me the commands that I can just copy and paste to download those things. I think that would be a great tool that I would just use every day, because now I have to like click and click and click and like find the SRR code and just like go back to terminal and just prefetch that thing, blah 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 blah. But I think if I could just like type in, hey, I'm looking for this type of data set, like can you just give me the SRR codes? I think that would be great. So yeah, do you have any plans for that SRA project, or it's just like a side project that you don't care about anymore?
I'll come on to that. First, I want to touch on the first thing you said, which is that you'd still download the report and read through it. 100%. AI summaries are in no way meant to replace what you're already doing with MultiQC reports. They are very much just a supplement. It's maybe, you know, just something to get you started, and you should not rely on them, and you should not stop looking at all the other stuff. So hopefully that's kind of obvious to most people, but I think it's worth saying out saying out loud. Then yeah, the other tool you mentioned is SRA Explorer. I think .info the URL is with a hyphen. This is a weekend project from many years ago now. Basically, in my previous life back in the UK, I was working in labour and bioinformatics group in Cambridge, and we were spending a lot of time fetching public data sets for people and processing them to then kind of use for internal analysis or comparison against internal data. So I spent many hours downloading, fetching data from the SRA, as I'm sure many people working in bioinformatics kind of are familiar with this. And my background is I've always been kind of a hobby web developer, and I just kind of got a bit frustrated with how many clicks it took and how difficult the interface was to navigate. And the SRA has a really, really good API that backs the whole thing. So I just was like, right, I want to sit down and teach. I think it's built using AngularJS, which really dates how old this project is, because that just doesn't really exist anymore. It's been replaced by Angular. But so it's really kind of a pretty horrible code base to look at now. It's a single HTML file with thousands of lines of JavaScript in it. But yeah, so and the concept, as you say, is you enter your search term the same as you would normally. But what I was trying to get towards is more like an online shopping experience where you can kind of browse and click the ones you want, add them to your kind of your basket, and then check out with a script which just hear all the bash commands you need to download the data or whatever, extract the metadata. So a couple of things I did since I initially did that weekend was I integrated it with the ENA, which is from the EBI in Cambridge. They host FASTQ files for most data sets. So what it does now is it takes the SRR numbers and it queries them, and then it gets the links to the FASTQ files, which means that you can download them directly rather than doing a conversion step, which a lot of people like. And then, yeah, I've done some tweaks here and there. Most recently, I've added in a little fun evening project again. I added an integration where you have like a table with all the metadata, and there's a button now which you can fire that into Secure Platform, which is my employer. That's the commercial side of what we work on, which means that you have basically one click to get into Secure Platform from where you can use it as an input for launching a pipeline. So it lives on a little bit, but it's an old project now. It's kind of painful to work on whenever I pick up the code base. So it's not abandoned, but it's limping on in maintenance mode. And yeah, you should pitch your idea, or maybe I should pitch your idea for the AI browser. It's a nice one. I mean, that's the thing that excites me most about AI now is all these kind of niche applications. Like the base models are getting so strong that the kind of what's really interesting, I think, is how we can apply it and integrate it into workflows and say, yeah, why not? You know, take your request, optimize an SRA query, fire it off, then, you know, iteratively refine the result set and, you know, give you a one-click solution. Sounds good.
Great. I mean, I think MultiQC AI summaries ties very nicely to this next question. so we know that like what happens with like bioinformatics tools most often is that so like they're developed by people like you with like a strong background in computer science and like software engineering, but a lot of users are just like wet lab people that like have very little coding experience, and like they want the best like like the easiest experience of just like I don't know, copy this, paste this, and just like this is how you run this thing. Um, so I was just gonna ask about like how do you bridge this gap, or like how do you plan to make this experience like very great for like people with no coding background?
Firstly, I want to mention that I don't have any formal training whatsoever of software engineering or coding. I was a wet lab scientist. I did my PhD in the lab.
Wow.
So don't be put off by thinking that you need to be in order to write software for bioinformatics. I think bioinformatics gets a lot of kind of stick for having software which is written by PhD students and abandoned or whatever, or not following, best practices from industry for software. But I think it's brilliant. Anyone can dive in, teach themselves, and write something that's useful for the general community. Like I love that. I love that about open source, and I love that about science and bioinformatics. You can go from writing a little script on your computer, to very little effort to turn that into a command line tool, and then publish it on Bioconda, and suddenly you're a software developer. So yeah, I think no prerequisites. That said, obviously we want to. We were talking about fair earlier. We want to make all the things we make as accessible as possible, and that includes to people who maybe haven't gone through the process of kind of picking up these tools and understanding how this ecosystem works. And that might be anything from not being comfortable using the terminal. I mean, once you've been using a command line for a few years, you kind of forget that it's not something that everyone's born with. Knowing how to like CD and LS and all this stuff like that, that's a skill that needs to be learned. And so, yeah, I mean, we spend a lot of time thinking about how we can make our software more accessible. The Sakura platform, which I mentioned, this is the tool that we build by Sakura, and it kind of sits as a layer above Nextflow. And this provides one of the main kind of selling features for it is it provides a graphical interface to do many of the things that you need to do for kind of real production level bioinformatics. Is all built on an API, so there is a command line interface to Sakura platform as well. But it gives you a point and click process where you can find a pipeline, import it, fill in a form with a web form with all the different inputs and everything, and run it, and then visualize the outputs without ever touching a command line. And that's a huge part of what we do. That's on the Sakura side, but that's all built on, we try and build the fundamentals for those into open source. And so NF core pipelines, the way we do this is we have a standard that we developed, which is called Nextflow schema, where we describe all the parameters and provide help text. And that's using the JSON schema format, which means anyone can build tooling around it to provide graphical or user-friendly interfaces. And kind of taking the same idea to other places. I mean, you can do it at every level. Like MultiQC has, I hope, fairly nice help output when you do -- help. And another little side project that span out of that was I made a Python library called RichClick, which integrates with two Python libraries that I love, one called Rich, one called Click. And with a couple of lines of code, you just take a code you'd already written with Click, and it formats it really nicely and gives you coloring and stuff. That's now like my most popular Python package I've ever written because it's not bioinformatics, and it's got like some terrifying number of like stars and downloads. I think it's got like however many million downloads now.
Wow.
So like, the user friendliness can be at all stages, from even people who are tech savvy using command line up to point and click interfaces and everywhere in between.
Great. Yeah, so let's do more technical questions. The pipelines leverage Nextflow DSL2, which allows modular workflow design. Given that some NF Core pipelines still use DSL1, I think, what were the biggest challenges in transitioning Ataxic, specifically Ataxic, to DSL2, and like what benefits have you observed so far?
hopefully not too many NF core pipelines left on DSL1. It's been a few years now. Yeah, so DSL1, DSL2, DSL stands for domain specific language, which is the kind of shorthand for talking about Nextflow as a programming language. We're trying to move away for that now as a project. And so my day job is I'm product manager for open source at Secura. I never said that in the intro. So I'm responsible for product management for Nextflow and MultiQC and Wave and some other tools. And we're kind of, I don't really like that lingo, but basically, yeah, think of it as Nextflow version 1, Nextflow version 2. That was probably the biggest seismic shift in the Nextflow ecosystem. For any Python developers, it was a lot like the shift from Python 2 to Python 3, where it came with lots of features and made things much better, but also brought a lot of pain for developers because suddenly you need to like rewrite your code or certainly refactor it to a certain degree. The good things that it brought were modularity, which you mentioned. If you look at old DSL1 pipelines, they are these monoliths. Like you have one main.nf script, which is thousands of lines code, and it's very difficult to pick your way through. It's also very difficult to share any of that code. If you look at DSL2 code within NF Core, we actually have a modules library. I was thinking of talking about this earlier when we were talking about FAIR, because I think it applies to the code as well. NF Core is more than just a set of pipelines you can use. It's also a developer framework. And so you can go into the module level and you can create yourself a pipeline very quickly. And then you can just drop in pre-built modules that have been written. So, a taxi, say, has 20 different tools. Yeah, you can just drop in those 20 different tools and we've got modules for each one. Each one comes with the software it needs. Each one comes with its unit tests. And then all you have to do is connect them and build up the parameters to control them in the way you want. So that modularity brings hopefully easier to read code, easier to maintain code, and also much more powerful ability to share and collaborate on units of code. What made it difficult was the fact that some syntax was depreciated, and basically there's certain parts of DSL1 pipelines which wouldn't work with the new version of Nextflow. Both were supported for quite a while, about a year or more, but as of Nextflow version 22.10, I think DSL1 was dropped. So now if you want to run those pipelines, you absolutely can. You just have to use an old version of Nextflow. I can't speak very much to AttackSeek itself because I wasn't hugely involved in that pipeline, but I was quite involved in some DSL2 translations. I was one of the people doing methalseek, for example, and a few others, and I was definitely involved at organization level. And there were lots of, it was a long road, but I think the way we tried to help with it at NF Core level was to provide tooling around these things. So there's a command line for NF Core, and we have developer tools for that. So we have like linting tools to check the code syntax. We have a template for modules, just as the same way we have a template for pipelines. So we have a kind of a whole system built up around this authorship, and that goes a long way to helping developers.
Great. I'm not sure if you answered this next question, but I'm just going to ask it anyway. So if you look at the GitHub, I think it suggests that like a per process containerization strategy, which is just one container per process. How do you decide which dependencies belong in the core container versus like those handled by NF Core modules? And have there been any unexpected benefits or trade-offs with this approach?
Yeah, so this was one of the main things. I should have mentioned this actually when converting from one to the other. In old DSL1 pipelines, we typically had one container image, Docker or Singularity, which had all of the software for the whole pipeline.
Yeah.
The benefit of that was that, especially if you're using Singularity, you have the software as a single file, and it meant you just had one file. And if you have 50 files with 50 images, they all have basically the operating system. Like maybe the bioinformatics tool is actually like a collection of 5 Perl scripts, but you have to bundle the whole container with it. And so the file size was bigger when you kind of break it up into per process like this. The benefit, though, of doing it per process and breaking it up is that we would hit compatibility issues between different software. So maybe a pipeline has one Python tool which needs Python 2 and another one which needs Python 3. And if they have to live together in the same container, it causes a lot of headaches. So packaging software so that you have one tool per container is generally much, much easier. We can take that to the extreme where we can use community resources. So NF Core very heavily uses a community called biocontainers, which is set up to, so BioConda is the main place where bioinformatics tools are packaged using Conda. And every BioConda package has a corresponding biocontainer, Docker, and Singularity image. And so this means we can you specify your Conda tool name, and then we can provide Conda and Docker and Singularity out the box with basically no additional effort. So it really, really streamlines the developer experience because it's just much easier to write. The other thing that's really important is that if you want to share modules, like these Lego bricks between different pipelines, then of course they have to have their own software. They have to be self-contained. And so it quickly became, when we moved to DSL2, it became essential that we have this set up. And now there is no one central container. The way you phrased it, it sounded a little bit like it was a choice, but it is not. Every process has its own container. And that's basically it. Some processes might have the same container, but each process has its own.
So looking ahead, what are the next big improvements planned for NF Core pipelines? Are there any high priority feature requests from the community that you're considering implementing?
Always. Yeah, we have many more ideas than we have time to do. But I mean, to pick a few, what are the major projects we're working on? We're thinking a lot about that Nextflow schema that I mentioned earlier. We use that for many things. We use it to build the help text page on the NF Core website. We use it to build launch interfaces in Secure Platform and Epitome Software and other places. We use it to validate all the inputs when you launch a pipeline, so you find out straight away that it should have been an integer and not a number. That schema has become quite a central part to what we do, and we have a lot of ideas of things we want to do, extend it to handle. JSON schema is quite comprehensive and we want to support more things. So we want to have more complexity in how you can structure that. And we're also rebuilding a lot of the tooling for writing those files yourself and kind of thinking how they integrate with Nextflow. So that's kind of a big area of focus. What else? I need to kind of get it straight. We've got a big old roadmap for Nextflow itself, which I'm very heavily involved with. The big focus there is to think about evolving the syntax. So at the end of last year, we launched a brand new language server for Nextflow, which basically gives the main thing you see is if you're using VS Code, we've got an updated VS Code extension, and it gives you all the kind of code intelligence that you're used to from writing with other languages. So you get things like quick code navigation. You can click on a symbol and it'll take you to where it's defined, or then it will give you little squiggly red lines if you use a typo and try and reference a variable that hasn't been defined anywhere. Stuff you kind of take for granted with other languages, but was missing from Nextflow until now, and makes a massive difference when you're developing code. And so that was released at the end of last year, and we're now kind of taking that forward, this concept of dropping the DSL and just handling Nextflow as its own language. And with that, we can start to really double down on the customization and how easy we can make it to write Nextflow pipelines and tailor the language to the use case, and remove some of the stuff that is coming from the underlying Groovy language, which is kind of confusing when you're a newcomer, which should hopefully make it a lot easier to read and write Nextflow code. There's a long other list. I'm going to pick one other thing. I would say we're going to change the way that software is packaged for NF Core. So I mentioned we've been using biocontainers for a long time. One of the other open source tools I'm involved with as product manager is a tool called Wave. And this is a system for working with Docker and Singularity images, where basically you put in a request for either a Docker file or a Conda package or a combination of Conda packages. And Wave will return it immediately if it exists, or if not, it will build it on demand. So you don't have to prepare every single Docker image you're ever going to need in advance. You just kind of grab them on demand. And it can do a lot of other clever stuff as well, like mirroring between different Docker registries so that you're pulling it from somewhere in your compute region on the cloud or augmenting it with additional binaries and stuff like this. Anyway, we are going to use that underlying tool to then start building all the software for NF Core, which is going to give us a lot of cool stuff. For example, we should be able to have containers for ARM64. So if you want to run with that CPU chipset, which could be a lot cheaper, we should be able to support that for almost all NF Core pipelines. We should be able to generate basically all this kind of different matrix of different software requirements. So Docker Singularity, ARM, Arch, Conda, also using Conda lock files, really beefing up how solid our software packaging solution is by automating all of this. I got a bit technical there, sorry, I got carried away.
No,
I'm
no, that's
excited about
fine.
it.
Yeah, I actually had some technical questions about Groovy that you just answered. But I would like to delve deeper into this AI automation. So do you see the potential for like AI-driven optimizations in NF Core pipelines, such as dynamic parameter tuning or automated troubleshooting?
Yeah. So one of the features we've had in Secura platform for quite a long time, I think it's maybe a bit underappreciated, is when you run a pipeline using Secure platform, after you've run it, in the launchpad, it has a little icon that looks like a light bulb. It says optimize. And if you click that, what it does is it looks at your previous run or runs of that pipeline. Nextflow collects a huge amount of information about CPU usage, memory usage, disk I/O, and it generates these reports from every single run. And basically, when you click optimize, it uses machine learning to look at all those numbers from previous runs, figure out an optimal Nextflow configuration with resource requests, and then save that as basically a custom config for that pipeline, which is something that's really difficult to do at like NF Core level because we have no idea what kinds of data people are going to run through pipelines. People use SAREC to do, massive deep sequencing of human cancer samples. They also use it on bacteria to do variant analysis. And so the resource requirements for those two different use cases are wildly different. But if you use this kind of machine learning approach, you can say, okay, run it once and maybe we're a bit wasteful with the resources. But the second time you run it with a similar data type, you know that you can kind of fine tune it. So that's actually already been there for quite a while. I think there's a bit of room for improvement in how some of the things it does, but so I'm looking forward to hopefully improving that in the future, but that's already there.
And that's
Also,
different from the Ask AI tool that you guys have, right?
yeah, so that exactly. The optimized one's been around for a while. Ask AI was released just at the end of last year at the Nextflow Summit in Barcelona in October. Ask AI is a chat interface, much more familiar to what people think of when you say AI. And it's the main thing it's launched with is the ability to really understand best practices Nextflow. And if you, I don't know if you've tried this, but if you're developing Nextflow code and you throw into ChatGPT or I don't know, Claude or whatever model you like, some question about your Nextflow code, it very often gives you incorrect answers. These models are trained on public code, and the majority of public code around Nextflow is old DSL1, and the answers it gives you and the code snippets it gives you are not good. And so it's a really frustrating experience. But so what we've done is kind of fine-tuning AI models so that when you ask Secure AI about help about the same thing, it knows the difference between DSL1 and DSL2. It knows about NF Core and best practices. And in fact, I think in the launch demo said, can you help me build a pipeline for RNA-seq? And the first thing it said is, you probably don't need to build it. There's a pipeline you can use here. So it's like, it's the equivalent of having an AI that is already a bioinformatician and knows about the Nextflow ecosystem. In the future, we're hoping to sort of build more and more custom features into this AI tooling. Already, it can write tests for your code and also run tests. So if you ask it, if you go back to that Summit demo, it's really nice. Sasha kind of walks through the process of converting a WDL pipeline into Nextflow, and then kind of it builds all the different processes and it writes unit tests for each process. And when it goes off and runs them, sees errors, fixes it itself. It's kind of an agentic approach where it can go off and kind of work by itself a little while. And really kind of there's many things that I think this is useful for. One of the most obvious things it's useful for is newcomers to Nextflow, because it can help you, and it can help you write code and also help you with errors. Also, if you're transitioning from another language and are not super familiar with the Nextflow syntax, it can translate really well and shortcut you there. So it's definitely like a user friendliness, accessible thing. But also because it's really integrated into a tool set that we use, and the domain, it can be very specialist. And I think that kind of specialist nature of AI tooling is really exciting.
Do you see a day where like users describe their problem in just like plain English, and the tool builds a whole pipeline for them?
Yeah, I mean, you can sort of start to do that now. It depends a bit on how complex your question is. But so I mean, you can already kind of say, build me a pipeline to do this, and it will come up with tool suggestions, and it will start to write processes for you, and it will certainly help you write the pipeline around that. I think as AI models get better and better, context windows get bigger and bigger, then the kinds of things you'll be able to ask of the AI systems get more and more complex. And so I mean, the speed that things are moving, I can't imagine it's going to be very long before we get to the place where, yeah, you can spin up a bespoke pipeline for your specific data type and your specific question in a few seconds. And then hopefully, save that and push it to GitHub and release it as software, which is reproducible and has all that good stuff we've been talking about earlier in the episode.
Mhm. Nextflow has become the dominant workflow manager in bioinformatics, but we have other things like SnakeMake and WDL, which are still widely used. What are the biggest philosophical and practical differences between these workflow languages? And do you think they will converge in functionality over time?
I mean, usually I've been asked this question for as long as I can remember, as long as I've been using Nextflow, really. My stock answer is that they're all good. And the most important thing is that if you as a bioinformatician uses one, and doesn't just use a bunch of bash scripts in a folder somewhere, um, they have very overlapping functionality in many ways. And so there's a lot more in common between them than there is that separates them. If pushed to look for differences, with the normal caveat that I'm heavily biased, of course, and really experienced only with Nextflow, but some of the key differences certainly between SnakeMake and Nextflow is that Nextflow is I forget the proper term for it now, but it basically whenever you do a workflow, you work with a DAG, diacyclic graph, where basically you kind of you have a big network of these are all the different steps in the pipeline. This is how a dependency graph between them. This is how they connect into one another. And Nextflow works this out as it goes along. It has this kind of push mentality, whereas the other workflow managers kind of look at what the output files are and work back from that and build up the whole graph before it starts anything. Because Nextflow works in this way, it comes with two advantages. Firstly, it starts immediately, and these graphs can be enormous. And so because it's figuring it out as it goes along, there's no delay at launch, which is nice. And the other thing is it can respond to results as it goes along and change it dynamically. So a very simple example is the RNA-seq pipeline, I think off the top of my head, checks the alignment results. And if the alignment is below like 2% or something, it will discard those samples from any downstream processing, because we know that the downstream steps will fail and the pipeline will crash if you try and analyze samples that have got effectively no zero reads. And so we can kind of look at the results of a step and change the downstream steps. And you can of course build much more complex logic around this as well. So that's one of the key advantages of Nextflow. Nextflow, aside from this, on a more practical level, has a reputation of being very good at scaling, which we talked about already, kind of handling very large workflows and kind of being really used for massive industrial kind of production level workflows. It's being used by, I can't remember the exact number, but most of the kind of top 20 pharma. And it's also, of course, got the community. So there's a lot
Yeah.
of people using Nextflow. There's a lot of people online we're a friendly bunch. So on the whole, if you hit some weird error that you don't recognize, or you want some help or some advice, it's not difficult to hop onto Slack or jump onto the community forum and usually get a pretty fast response.
Yeah, I mean, I personally don't know much about like the technical behind the scenes. So I mean, there's no way for me to like say which one is like technically superior. But as you said, like as just an end user, for me, the community is amazing, and like you guys have like hackathons, events, like talks. You have your own podcast. You come to other people podcast. So for me, it's just a very pleasant experience that I know I'm not lost if I bump into any problem down the road using this thing. And I think for me, like that's one of the main features that I just want to keep using these tools. Um, you have mentioned that Nextflow is integrating static type checking and improved syntax validation. Do you think these changes will make Nextflow more appealing to software engineers outside of bioinformatics and potentially increasing cross-discipline adoption?
Yeah, I hope so. This work is building on that language server that we've created, which can do static analysis of Nextflow code, whereas previously it was always just kind of runtime. Some of that analysis is very obviously useful to anyone writing Nextflow code, because it means that it's going to catch syntax errors or other problems earlier. It's much better to know about an error in your code the moment you press the character on your keyboard, rather than when you've done a whole load of other stuff and then hit run and then waited 2 days for it to fail halfway through a pipeline run. The sooner we can tell people about errors, the better. So that's the number one driver for all of this, I would say. And static typing basically kind of takes this an extra step. What we mean by static typing is it'll be familiar for anyone who's worked very obviously with TypeScript versus JavaScript. Also, kind of Python 3 typing is coming in, and many other languages are strongly typed from origin. And basically, what it means is you have a variable. When you define a variable, you say what kind of data that variable should contain. Should it be a string? Should it be an integer, a number? Should it be a Boolean, true, false, and so on? And those types can be very complex. So you could say it has to be an enum, like enumerated value. So it has to be one of these 4 things, and it refuses to contain anything else. And when you have this kind of static typing, you can build that into the pipeline code, and it makes this validation much stronger. So as soon as you try and give a variable something it shouldn't have, it's going to throw an error straight away, and you'll see that when you're writing the code. And the other thing is we can be cleverer with the tooling. So maybe we have more built-in help text. You hover your cursor over the variable name, and it tells you what it's got inside it, rather than you trying to guess from whatever it's been named. And just loads of stuff like this. It brings more formality to the language, which means we can build much more tooling on top. I think in terms of will it be more appealing to traditional software developers, I imagine it will have that effect, because kind of people from that background are familiar with this way of writing code and maybe frustrated that existing Nextflow code is a bit kind of, you can get away with being sloppy. But really, that's not the primary driver for developing it. I would say the main reason is to improve the developer experience for everyone who's writing Nextflow code.
Great. If you had unlimited resources, what is one fundamental change you would make to Nextflow or MultiQC that could radically transform bioinformatics workflows over the next decade?
Or if I told you that, I'd have to. It's going to kept within the secrets of product management. I mean, there are many things. Ranging from simple that, I think there's probably I think we try and keep MultiQC under 200 open issues at any time. That Vlad, who works on MultiQC, it's like his personal crusade to do that. Just if I had unlimited money and time, I think that's probably one of the things I'd start off with, is just like, okay, let's clear the backlog. There's a constant kind of prioritization going on about which things do we tackle? There's so many ideas coming in from the community. And it'd be wonderful just to be able to say, okay, let's do all of these things. But that's not really a blockbuster for you. Um, hmm. Yeah, I have some ideas for different projects. Um, there's nothing. I think there's nothing that really springs to mind that's like one single thing. I I imagine a future where there's like a tapestry of new features which kind of bring together a kind of an experience and like it's a whole like ecosystem. Like building Secure platform, formerly called Nextflow Tower. I mean, if you look at where we started with that, it was a platform to monitor Nextflow runs. That's how we started. And then it became a system to launch Nextflow runs. And then it became a system which could set up cloud computing infrastructures for you using Forge, as it's called. So you put in your AWS details or whatever and hit create, and it builds all the infrastructure for you. And then more recently, we've added kind of Data Explorer to like be able to browse your buckets and your data. And we've added data studios where you can have VS Code or Jupyter notebooks running in interactive sessions. And kind of the way I see this, like the platform gets wider. We started with this one central thing and we slowly kind of build our way out. That's still the core, most valuable thing that we work on is running pipelines and monitoring pipelines. But if I had infinite kind of money and resources, I think there are so many different parts of the daily work and the scientific life cycle, which could be improved. I would love to just take up all these different projects and do them all at once, rather than kind of, and really sort of each one by itself might not be huge, but together you can really build this kind of really kind of enjoyable ecosystem where everything flows smoothly, and remove all the friction points.
Great. Thank you so much. I love this conversation, and I think it was very insightful. Two things before we wrap up. You guys have a hackathon coming up, right?
Yeah, well, we actually,
Yeah, yeah.
as of like yesterday, I think the NF Core website has 3 hackathons listed,
Mhm.
because we just launched the dates for the 2 upcoming Nextflow summits as well. But yeah, no, we have a hackathon in March, which is our
Mhm.
online/distributed hackathon. What I mean by that is anyone can join from anywhere, just on your computer. You hop into our online system for that, and join on Slack and wherever else. So that's kind of a primary focus, but also many people are organizing local sites, which could just be booking a meeting room wherever you work and sort of inviting people to come and join you. I think the last time I checked, we had something like 40 different sites all the way around the world. Let me check. You can go on the NF Core website and see a little map, which I find very satisfying. 43 different local sites in 27 different countries, across all time zones: New Zealand, Australia, the US, South America, Africa, Asia, Europe. So really, really spread. And I'm hoping we'll get, my guess is 500-600 people joining for that hackathon. So it's going to be really big, really fun. And it's open to
What
everyone who
happens?
does.
Yeah, and what happens exactly in these hackathons?
So I mean, really, it's up to everyone who joins. Some hackathons are quite formal. Like you might have heard of other hackathons that are competitions, or there's like a target for you to do, or different projects. The NF Core ones, I mean, we've talked about dropping the name hackathon before because it doesn't really fit that convention. But basically, if you have a project that you want to work on, then great, bring it and work on it. If you don't have anything, you just want to spend some time being familiar writing Nextflow code, join it and you'll find someone else. Just have a look through the list of projects that people have submitted and pick one that sort of sounds interesting. Maybe it's a pipeline which is related to some data that you work on. If I look at the projects now, I think there's one for a new pipeline that's been built called Seek Inspector, which is all about QC of genomics data. So maybe that sounds interesting and you hop in. Or there's one about software packaging for ARM if you're super techie, or there's one about single cell expression atlas. So you can kind of, there's like a big shelf of different projects you can pick. And some of them are pipelines, some of them are helping to build the website. So not even, or it depends if on your background about what you kind of find interesting. And then we basically do that kind of for 3 days wherever you are. You don't have to stay up at night. It's just 9 to 5 wherever you are. And we have, some socials, like some quizzes, and, if you're in a local site, we'll buy some pizza for you and send you some stickers.
Yep.
So they're a lot of fun, and we kind of, there's a lot of activity, and everyone's very chilled. So it's good fun.
And how can one register for this event?
So if you go to the NF Core website, if you just Google NF Core, then at the top you'll see a tab. On the top tab it says community, and then there's a section that says hackathons. And if you click on that, you'll see all the past hackathons that have happened, but then also these 3 that are coming up, because there's also an in-person one at the Nextflow Summit in May, which is in Boston in the US, and then in October in Barcelona in Europe. So you'll see the 3, the online one, the Boston one, and the Barcelona one. And if you click through to any of them, there's information about registration now. The online one is totally free to register for.
Amazing. And so, last question, we usually go like advice for grad students, but I think knowing what I know about you now, I think I would say advice for people in wet lab who want to learn programming or something like that.
Yeah. I would say find a project. That's how I got started. I got into bioinformatics because the people I was relying on to do my analysis for me were busy, and I went and knocked on their door and was like, is there anything I can do just to, speed it up a bit? And the rest is history. I think it's personally, from my experience, I find it quite difficult to read books and write. Some people really thrive on that, but I need a project. So that's usually what I tell people is, you might be only a wet lab scientist who doesn't know anything about code, but you are an expert in whatever it is that you do with your research. So find some aspects of it which has data, and then start working with it and see what you can pull out of it. And find online communities and don't work in isolation. You dive into NF Core. We have these almost weekly bite-sized talks, which always go out on YouTube. And we have 80 plus of these 15-minute videos now, which cover some quite complex topics, some about pipeline specific scientific topics. Some of them are like, what is GitHub and how do you create your first ever pull request? So really targeted at beginners. There's loads of materials out there, and there's lots of people willing to help you. So don't be scared to ask questions. Don't fight that imposter syndrome and just try and build something.
Great. Thank you so much. I really enjoyed this conversation. And I just want to say I use your tools, NF Core, pipelines, Nextflow, and all these different sort of tools every day in my research, my master's research, now in my PhD research. And I'm sure many people are just like me, rely on these tools every day for their research and what they do for work. And I just want to appreciate you. Thank you so much.
Thank you very much. It's been a pleasure. Thanks for inviting me now.
Thank you so much for listening. If you made it all the way to this point, you might be interested in genome-wide association studies as well. So if that's the case, check out our second episode with Dr. Talion, where we talk all about GWAS and its implications.